Hello everyone and welcome to the first lecture of mole concept. Mole concept also happens to be our first topic in 11th standard, and often some students find it slightly confusing. I'll try my level best to make it as simple as I can. So let's get started. Before we jump to the core of mole concept, let us make ourselves familiar with some basics. We will see some subatomic particles and their masses. So subatomic particles, we have electrons, protons, neutrons. In an atom, there is a nucleus. That nucleus contains protons and neutrons, and the electrons revolve around that nucleus. And since protons and neutrons are present inside nucleus, they are commonly called nucleons. So nucleons is a common word for proton as well as neutrons. Now look at their masses. A proton and a neutron. The masses are approximately same, which is 1.67 into 10 to the power minus 27 kilograms. When written in grams, we will multiply it by 1000 to convert it into grams, and we will get 1.67 into 10 to the power minus 24 grams. Point to be noted, 10 to the power minus 27 kilograms and 10 to the power minus 24 grams. Now this is an approximated mass that I have taken. In some textbooks, you might find it 1.66 into 10 to the power minus 27 and so on. So 1.66 or 1.67 dono chalega, absolutely no issue with that. Now check the mass of electrons. Mass of electron is 9.1 into 10 to the power minus 31 kilograms, or 9.1 into 10 to the power minus 28 grams. This is far less than the mass of a proton or mass of a neutron. I will use a common word, nucleon. Whenever I say nucleon, you have to understand I'm referring to proton or a neutron. Just to give you a context, 10 to the power minus 1 means 0.1. That is, after decimal, at the first place 1 is there. 10 to the power minus 2 means 0.01. That is, after decimal, at second place 1 is there. Likewise, when I say that weight of or mass of a nucleon is 10 to the power minus 24 order, what I mean by that is that there are 23 0 0 0 like the 23 zeros, and then there is 1. That is, this is an extremely small number. This is such a weight that we cannot even imagine it. For example, if I give you this pen and then I say, okay, what must be its weight, you have some idea. Okay, maybe this is 10 grams, maybe this is 20 grams. Nobody will say that this is 1 kilogram. So we have some idea, some sense of how much 1 kg or how much 10 grams or how much 1 gram is. But we have absolutely no idea of how small this number is. So to put it in context, it is an extremely small number. Now since it is slightly lengthy, writing it every time 1.67 into 10 to the power minus 24, slightly inconvenient. So what we say is, instead of writing it in grams, we will simply say that mass of a proton or mass of a neutron is equal to 1 unit. 1 U. U means unified mass, and old convention, old style of writing was 1 AMU, atomic mass unit. AMU stands for atomic mass unit. U stands for unified mass. Both means the same. AMU is slightly old way of writing. U is new way, new convention of writing. Okay. So what is 1 U? 1 U is same as 1.67 into 10 to the power minus 24 grams. 1 U or 1 AMU is equal to 1.67 into 10 to the power minus 24 gram. We have to remember this, that 1 AMU or 1 U, I may use them interchangeably, don't get confused. Okay, 1 AMU is 1.67 into 10 to the power minus 24 grams. That is 1 U or 1 AMU is simply 1 U or 1 AMU is simply mass of 1 proton or mass of 1 neutron. Point to be noted. 1 unit means 1.67 into 10 to the power minus 24 grams, or 1 unit means mass of a nucleon, mass of a proton or mass of a neutron. Since it is slightly lengthy, slightly inconvenient for us to write that big number every time, as in the number itself is very small, but writing wise it is slightly lengthy. So for short, for our convenience, we'll say that it is 1 unit. The second thing that I would like to draw your attention to is mass of electron. The mass of electron is much smaller than the mass of a nucleon. Like over here, 10 to the power minus 2 is a smaller number in comparison to 10 to the power minus 1. Likewise, 10 to the power minus 28 is much smaller number than 10 to the power minus 24 grams. So, second thing is that mass of an electron is much lower, very less in comparison to mass of a proton or mass of a neutron. It is found that mass of a proton or mass of a neutron is approximately 2000 times mass of an electron. That is, a proton is approximately 2000 times heavier than electron, and hence we say that mass of an electron is negligible in comparison to mass of a nucleon. It is like, let us say that there is one billionaire, a very rich person is there, and his net worth is around 10 billion rupees. 10 billion rupees. Okay. And in that 10 billion rupees, if you add 1 rupee, will it make any difference? So 10 billion plus 1 is how much? Again, you will say, sir, it is approximately 10 billion. 10 billion and 1 rupee need not be said. Why? Because 1 rupee is insignificant, or insignificant in the sense negligible in comparison to 10 billion. Likewise, when we consider the weight, the mass of a proton and mass of an electron, we say that mass of electron is negligible in comparison to mass of a proton. So if you come across something like this, mass of a proton plus mass of an electron, you can say, sir, this is fairly okay to write mass of a proton. उसमें इलेक्ट्रॉन का वेट ऐड करने की नेसेसिटी नहीं है. You will skip it. You will say, in comparison to mass of a proton, electron is very negligible. So what is the point of adding it? You will skip it. So these 2 points are extremely important. First point is, what is the mass of proton and neutron? Well, they both have equal masses approximately, which is close to 1.67 or 1.66 into 10 to the power minus 24 grams. For our convenience, we will say that instead of writing 1.67 into 10 to the power minus 24 every time, we'll simply write 1 unit. So mass of a proton or mass of a neutron can be written as 1 unit or this many grams. Second point which is important is that mass of an electron is negligible, is extremely small in comparison to mass of a proton or mass of a neutron. So remember this number. Let us move ahead. Let us make ourselves familiar with atomic number and mass number. Atomic number means the total number of protons present in an atom, and mass number means total number of nucleons, total number of protons plus total number of neutrons present. जैसे कि अगर हाइड्रोजन का एटम ले ले, if you take an hydrogen atom, then you will see that hydrogen atom has 1 proton inside it, and then there is an electron revolving around. So what is the atomic number of hydrogen? Number of protons, 1. Atomic number of hydrogen is 1. Atomic number is written like this over here. And what is the mass number? Protons plus neutrons. 0 neutrons, 1 proton. 1 plus 0, answer is 1. By the way, hydrogen is the only element in the entire periodic table who has no neutrons. 0 neutrons are present inside it. Okay, so this is the way of writing. Over here, we write atomic number, which is denoted with Z. And over here, we write mass number, which is denoted with A. What is A, sir? A is number of protons plus number of neutrons. What is Z, sir? Simply number of protons. Let us look at helium atom. Helium has a nucleus which has 2 protons inside it and which has 2 neutrons also inside it. 2 electrons revolve around this nucleus. Helium atom therefore has 2 protons, therefore the atomic number of helium is 2. Atomic number यहाँ पे लिखेंगे. And the mass number of protons plus number of neutrons, 2 plus 2, 4. So what is the A for it? 4. What is Z value? 2. If I subtract A minus Z, if I do A minus Z, what is A minus Z? A is mass number, that is number of protons plus number of neutrons, minus what is Z? Number of protons. P minus P 0 हो जाएगा plus N. So I will get A minus Z, I will get number of neutrons. For example, here 4 minus 2, the number of neutrons are 2. If I represent lithium, let me say it is 3 over here, it is 7 over here. Sir, mass number 7, atomic number 3. The mass number minus atomic number will give us number of neutrons. Number of neutrons in the lithium atom would be 7. Mass number minus atomic number 3. 7 minus 3, answer is 4. So this is how we represent any given atom. So this representation I mentioned here in the next slide. जैसे कि अगर बात कर ले कार्बन की, कार्बन has 6 electrons and therefore 6 protons. Number of protons and number of electrons are equal for neutral atom. Okay, so it is going to be 6. Number of protons are 6. Number of neutrons are also 6. So 6 plus 6, number of nucleons are 12. So this is how we represent carbon 12. There is another isotope of it, which is called carbon 14, which is represented this way. Isotopes are the atoms of same element, carbon, same element, same atomic number, but different mass number. So whenever we are going to say carbon 12, we refer to this particular fellow, this isotope, carbon 12 isotope. The other one is carbon 14 isotope. Let us find the number of neutrons. Number of neutrons in carbon 12 is 12 minus 6, which is 6. Number of neutrons in carbon 14 is 14 minus 6, that is 8. So we can fairly say that carbon 14 has 2 extra neutrons than carbon 12. Likewise, even hydrogen is found in 3 different isotopes. This is normal isotope which I discussed. The other isotope has 1 neutron. See here, 2 minus 1, 1 neutron. The third one has 2 neutrons, 3 minus 1, 2. This isotope of hydrogen, which has 0 neutrons, number of neutrons 0, is called protium. Whenever we say hydrogen, we are referring to this hydrogen, that is protium. Another isotope has 2 minus 1, number of neutrons is 1. इसको बोलते हैं deuterium. This is called deuterium. And the third guy has, you see, 2 neutrons. It is called tritium. So these three are very famous isotopes of hydrogen. I hope it is clear to you this representation of atom. Here we write atomic number. Atomic number is number of protons, and here we write mass number, which is number of protons plus number of neutrons. All right. Now let us try to figure out what must be the mass of a single hydrogen atom. So let us take single hydrogen atom. Let us take single hydrogen atom. So single hydrogen atom, I told you, has one proton inside it and electrons, one electron around it. अगर मुझको पूछा जाए what is the mass of hydrogen atom? Mass of hydrogen atom. At first you might say, sir, it is mass of protons multiplied by number of protons. Okay, P is not a very good number, very good representation. We will say Z. Why, sir? Because number of protons is called atomic number represented by Z. So mass of a single proton multiplied by Z plus mass of electron multiplied by number of electrons. In neutral atom, it will be same as number of protons. Now if I tell you mass of electrons you ignore, put it equal to 0. Does that make sense? Absolutely. Why? Because I told you already, mass of electron is negligible and therefore it has to be ignored. You don't have to add mass of electron when calculating mass of an atom. Why? Because the mass of electrons is negligible. It is extremely small in comparison to mass of proton. So therefore the mass of a hydrogen atom is mass of a single proton. What is the mass of a single proton? It is 1 unit. Multiplied by the Z value, number of protons is 1. So answer is 1 unit. So mass of a single hydrogen atom is how much? It is 1 unit. In terms of grams, I told you 1 unit is same as 1.67 into 10 to the power minus 24 grams. You have to remember this. On the other side, if I take helium atom, so helium atom has 2 protons, 2 neutrons. And of course, there are 2 electrons revolving. When I'm taking the mass of helium atom, I will only look at the mass of nucleons and I will ignore these electrons. Why, sir? Mass is negligible. So total number of nucleons, there are 4. Total number of nucleons multiplied by total number of nucleons is A, mass number is A, multiplied by mass of each nucleon. Mass of each nucleon may be written as mass of a proton or mass of a neutron. Why, sir? Because they are same. Each proton and each neutron, their weight will be the same. There is no difference. Mass of proton is also this much, mass of neutron is also this much. Absolutely no issue. So what is mass of a single nucleon? 1 unit. A unit. And what is A? A is the mass number. In this case, it is 4 units. So how much will a single helium atom weigh? 4 units. But since it doesn't give us a good idea because we are used to grams, you may also convert this into grams and you may say 4 units. Sir, 1 unit is how much? 1.67 into 10 to the power minus 24 grams. This is how we can calculate even the mass of an extremely tiny atom which we can't even see with even a simple microscope. So we need a very sophisticated microscope to look at such tiny atoms. Yes. Now coming to this main topic, I already explained, but let us define what is atomic mass unit. Atomic mass unit, in simple terms, we will read the definition, but in simple terms, 1 atomic mass unit is equal to mass of 1 nucleon. I already told you. 1 atomic mass unit means simply mass of a nucleon, that is mass of a proton or mass of a neutron. And how much it is equal to? 1.67 into 10 to the power minus 24 grams. 1.66 or 1.67. It is one and the same thing because we have approximated. It depends. So how much is 1 AMU? 1.67 into 10 to the power minus 24 grams. Achha. What is the formal definition? One atomic mass unit is defined as mass exactly equal to 1/12th mass of one carbon 12 atom. Now it is clear. Carbon 12 means which one? This guy. This guy. Fine. So let us see. Let us look at a carbon 12 atom. Carbon 12 atom has a nucleus which has 6 protons and 6 neutrons. Okay? And of course there are electrons going around. There are 2 electrons here and the rest 4 are outside. That's okay. So mass of a single atom, mass of carbon 12 atom will be how much? Simple, sir. It is simply mass of 6 protons plus mass of 6 neutrons. So we can say 6 plus 6, it has 12 nucleons. It has how many nucleons? 12 nucleons. Into mass of each nucleon. What is mass of each nucleon, sir? Sir, what is mass of each nucleon? Sir, mass of each nucleon is simply 1 unit. Is simply 1 unit. So mass of carbon 12 atom is 12 unit. अभी definition क्या बोल रहा है? 1 unit is simply 1/12th of this. 1/12th means divide by 12. If you divide 12 units by 12, you will get 1 unit, which is 1 AMU, 1 unit. So by definition, 1 unit is weight of carbon 12 atom. How much is that? 12 units. Divide by 12. 12 divided by 12, you will get our answer. I can also convert, okay, in other way, I can say 1 unit is equal to mass of 1 hydrogen atom, because mass of 1 hydrogen atom is 1 unit. Or I can say that mass 1 AMU is equal to mass of helium atom divided by 4. That is 1/4 mass of a single helium atom. Mass of single helium atom 4 unit. 1/4 of it means divided by 4. 4 unit divided by 4 is 1 unit. So I can define the mass 1 AMU in terms of mass of any atom. But technically, for some technical reasons, we specifically define AMU in terms of carbon 12 atom only. जैसे कि अगर मुझको बोल दे कि कार्बन 14 एटम दे दिया हमको, इसका मास कितना होगा? इसका मास होगा सर, इट हैज 14 न्यूक्लियॉन्स एंड ईच न्यूक्लियॉन वेज 1 यूनिट. तो इसका यूनिट कितना होगा? 14 यूनिट. So if I have to define 1 AMU in terms of carbon 14, I'll say it is 1/14th of mass of single carbon 14 atom. Single carbon 14 is 14 units. Divided by 14, बस बात खत्म. So likewise, let us make ourselves familiar with some numbers here. All right. Hydrogen mass number means number of nucleons. Mass number means number of nucleons. It has 1 nucleon. 1 nucleon weighs 1 unit. इसका atomic mass हो गया 1 AMU or 1 U. Anything is fine, no problem with that. Helium has 4 nucleons. Each nucleon weighs 1 unit. 1 unit plus 1 unit plus 1 unit plus 1, total 4 units. Likewise, all other guys. So simply if we have mass number, we will simply put U in front of it. We will say that's its atomic mass. What is atomic mass? Mass of a single atom. And when we calculate mass of a single atom, when we calculate atomic masses, we ignore the mass coming from electrons because it is extremely, extremely small. Okay, fine. Let us look at nitrogen. Nitrogen कैसा है मेरे भाई? Nitrogen has 14 nucleons. Therefore, its mass is going to be 14 units. Carbon 14, also the mass is going to be 14 units. Single atom will weigh 14 units. Now look over here at this guy. There is a problem. Okay. Chlorine, its mass number is 35, but its atomic mass is 35.5. 1 unit means 1 nucleon. That's understood. 35 nucleons means 35 units. 35 mu. Why have I written 35.5? Because if I write 0.5, I am implying that there is half a nucleon present. There is half a proton present, or there is half a neutron present, which is impossible. This cannot happen. So whenever you come across such numbers, point something, 0.5, point something, you must understand that it is not a atomic mass of a single atom. It is atomic mass, but average atomic mass. It is an average atomic mass. Let us see what we mean by average atomic mass. Chlorine is found in nature in two forms. One is chlorine with 35 nucleons, and other is chlorine with 37 nucleons. Very much like carbon. Carbon 12 is found, carbon 14 is found, like that. Chlorine is found in predominantly these two forms, chlorine 35 and chlorine 37. In nature, their percentage, both of them have significant percentages. Out of total chlorine which is found in the nature, 75% of that chlorine is Cl35 and 25% बाकी का जो बचा है लगभग वो ये है. So now we are faced with one question. In that case, what should be the mass number of chlorine? Should it be 35? Should it be 37? The confusion हो गया. So in that case, we figure out average atomic mass. Average atomic mass is mass number of first guy multiplied by its percentage, which is 35 multiplied by 75 upon 100. Percent means out of 100. So 75% means 75 upon 100. Plus mass number of the second guy multiplied by its percentage. That is 37 multiplied by 25 by 100. If you work this out, the answer will come very close to 35.5. That's why we take it to be 35.5. Now, of course, you will have a question, sir, but carbon is also found two ways, no? Sir, carbon 12 भी होता है, carbon 14 भी होता है, तो बात तो सही है. But the percentage nature, मैं approximately लिख रहा हूँ because you don't have to remember this also. Almost more than 99% of what is found in nature is carbon 12. ये लगभग 1% और in fact less than 1% है ये. This guy is less than 1%. So even if you find the average, it will come very close to 12. It won't go 13 or it won't become 12.5. All right, you can try it yourself. So that's why we don't have to consider the average atomic mass of carbon 12, but we have to consider average atomic mass of chlorine. That is because both the isotopes, chlorine 35 and chlorine 37, have significant proportions present in nature. So I hope that it makes clear why this 35.5, this number has come. All right. These numbers, that is mass numbers and their atomic masses, are extremely important for us. So you please make a note of them, because we are going to use them now. All right, let me move ahead. Yes, we are now moving to molecular mass. तो थोड़ा ध्यान दें यहाँ पे. ये हाइड्रोजन का एटम है, ये हाइड्रोजन का एटम है. When two hydrogens combine, when two hydrogen atom combine, then they will form H2, जिसको कि हम बोलेंगे मॉलिक्यूल है. ये मॉलिक्यूल है. So two hydrogen atoms combine form a hydrogen molecule. Similarly, two oxygen atoms combine and they form O2 molecule. So molecule is simply combination of atoms. Simply combination of atoms, उसको हम molecules बोलेंगे. नाइट्रोजन, दो नाइट्रोजन्स जुड़ गए तो बोलेंगे N2 molecule हो गया. Two hydrogens plus one oxygen, then we will have water molecule. So now, so far we know how to calculate mass of a single atom. Now we are going to check how we can calculate mass of a molecule, and it's quite simple. It's quite simple. Okay, तो थोड़ा ध्यान देना. Mass of water, ये molecule है अभी, is equal to mass of a single hydrogen plus mass of another hydrogen, since there are two guys, plus mass of oxygen. You know that hydrogen has one nucleon and oxygen has 16 nucleons. Altogether, one nucleon will weigh 1 unit plus 1 unit plus 16 units. Total 18 units. That's how we have that answer 16. और एक करेंगे, CH4 कर लेंगे. CH4 is simply mass of a carbon, there is only one carbon, and 4 times mass of hydrogen. One carbon weighs 12, मैंने बोल दिया already, carbon 12 ले लेते हैं हम. So then this is 12 plus hydrogen is 1, 4 into 1 is 4, answer is 16 units. Can you convert 16 unit into grams? Yes, you will simply multiply by which number? 1.67 into 10 to the power minus 24 grams. Boom, your answer is done. Likewise, Cl, I told you, each Cl is 35.5 multiplied by 2, answer आ जाएगा 71. Calcium, its mass number is 40, therefore 40 units. Sodium, its mass number is 23, therefore 23 units. One sodium atom is 23 units, oxygen is 16, hydrogen is 1. 16 plus 1 plus 23, you will get answer to be 40. So as simple as this. So once you have understood what is atomic mass, what is the mass of a single atom, you simply add it up. Whatever is present in the molecule, you will get a molecular mass. So molecular mass is simply sum of masses of all the atoms present inside it, and molecular mass as well as atomic mass we will express in terms of unit. The point to be understood over here is when we say atomic mass, we refer to mass of a single atom, and when we say molecular mass, we refer to mass of a single molecule. Find the molecular mass of H2. Quite simple. H2 has 2 hydrogen atoms and each guy weighs 1 unit. Therefore, answer will be 2 units. What is the molecular mass of H2? 2 units. Likewise, what is the molecular mass of N2? Each nitrogen weighs 14 units. The answer will be, this is 14, this is also 14. Total answer is 28 units. Likewise, oxygen. Each oxygen weighs 16 units. Answer will be total 32 units. Coming to fourth one, NH2CONH2. Well, let us see. There are 2 nitrogens present. So I will write 2 times mass of nitrogen atoms. Plus, there are 2 plus 2, 4 hydrogens, so 4 times mass of hydrogen atom, plus mass of a carbon plus mass of oxygen. Nitrogen I told you is 14. 14 into 2 is 28. Hydrogen is 1, we already know it. Plus carbon is 12, plus oxygen is 16. 16 plus 4, 20. 20 plus 12 plus 28. 20 plus 12, 32. Plus 28, total 60 units. The name of this fellow is urea. You might have heard this word urea. Urea is used as fertilizers. In fertilizers it is used. Okay. C6H12O6, you might have learned this in school. This is called glucose. Can you figure out the mass? Well, it's quite simple. There are 6 carbons, plus there are 12 hydrogens, plus there are 6 oxygens. So bhai kya hoga? 6 into carbon is how much? 12. 6 into 12 is 72, plus 12 into 1 is 12, plus 6 into oxygen is 16. 16 into 6 is 96. So this is 96, this is 84. Answer is 180 units. So 180 units. Can you convert that into grams? Of course, sir. We'll simply multiply it by 1.67 into 10 to the power minus 24. Likewise, now I won't solve this entirely. Iska kitna hoga mass? This will come to 342 units. 12 into 12, 144, plus 22, plus 11 into 16, 176. तो टोटल ऐड करेंगे 342 नंबर आ जाएगा. Okay, fine. Okay. Now coming to the core topic of mole. What is 1 mole? Well, it's quite simple, and it's simple counting that we are doing. So from now on we are simply doing counting business. Very much like if I tell you that we have 1 dozen of apples. How many apples do we have? 12 apples. Likewise, if I tell you 1 dozen books, so how many books we have? We have 12 books. So the word 1 dozen is immediately converted into number 12. Likewise, we have 1 mole. 1 mole is 6.022 into 10 to the power 23. It's a very big number. 10 to the power 23 means 1 followed by 23 zeros. My God, it's an extremely big number. We cannot even imagine this number. Okay, so very much like 1 dozen means 12 particles or 12 entities. 1 mole means 6.022 into 10 to the power 23 entities. Entities means items, things, jo bhi, whatever you like. Okay, entities means things, particles, items. So when I say 1 dozen, it automatically is to be translated into 12. Then I will say apples. 1 dozen apples, 12 apples. 1 dozen pens, 12 pens. So 1 dozen कुछ भी हो सकता है. Likewise, 1 mole का भी कुछ भी हो सकता है. Okay. 1 mole of electrons I may have. 1 mole of atoms I may have. 1 mole of molecules I may have. Now students get confused between mole and molecule. अलग चीजें हैं भाई, अलग चीजें हैं. 1 mole means like 1 dozen, it is a unit. 1 mole of something means 6.022 into 10 to the power 23 of those things. And a molecule is simply combination of atoms. Like H2 is a molecule, O2 is a molecule, H2O is a molecule. So don't get confused between mole and molecule. They are not the same things. They are completely different things. चलो यार आते हैं. 1 mole of hydrogen atoms means how many atoms? 6.022 into 10 to the power 23 hydrogen atoms. 1 mole of electrons means how many electrons? This many number of electrons. Now it's slightly lengthy writing it every time. 6.022 into 10 to the power 23. This number is also called Avogadro number and written like this: n subscript capital A, n then small a, means Avogadro number. The scientist Avogadro, this person, he gave this number. So in his honor, this number 6.022 into 10 to the power 23 is called Avogadro number. Or while writing, we will simply write Na. जैसे कि 1 mole electrons means how many electrons? Na electrons. But what is Na? ये number. 1 mole of hydrogen molecules means how many hydrogen molecules? Na hydrogen molecules. Likewise, 1 mole of water molecules means how many molecules? Na number of water molecules. So don't get confused here. 1 mole of molecules, हाँ हो सकता है. 1 mole of atom हो सकता है, 1 mole of proton हो सकता है, तो 1 mole of molecules क्यों नहीं हो सकता? Definitely हो सकता है. Let us try to figure out this one. How many hydrogen atoms are present in 2 moles of hydrogen atoms? Well, it's quite simple. We'll say 1 mole of hydrogen atoms we know is 6.022 into 10 to the power 23 atoms of hydrogen. ये तो हमको पता है. तो फिर 2 moles will be how much? 2 moles will be how much? आसान सी बात है, इसको यूनिटरी मेथड से क्रॉस मल्टीप्लाई करो. 1 into x is x equal to 2 into this number. So answer will be 12.044 into 10 to the power 23 atoms. See, these atoms, these electrons are very, very tiny things. We cannot speak in terms of dozens for them. We have to use a very big number. Like for example, when you measure gold, since gold is a very precious metal, you are going to purchase it in terms of grams. But if you are purchasing iron rods, then you may purchase them in terms of kilograms or in terms of tons. Limestone in terms of tons. Coal in terms of tons. Gold in terms of grams. If you are buying some spice in terms of grams. Likewise, if we are going to measure distance between 2 cities, we will often use kilometers for that. But how far is some galaxy from Earth? We are going to measure that in terms of light years. How far is certain planet? How far is certain black hole from here? We'll measure it in terms of light years because the distance is huge. We will not measure in terms of centimeters. Okay. Likewise, when we are counting the number of electrons, which are tiny, entities, we cannot measure them in terms of dozens. Because dozens is used for those entities which are present in less quantity. जैसे कि apples, you will not have huge number of apples. Huge का मतलब मेरा है कि बहुत huge. You might have 100 apples, you might have 1,000, you might have 10,000 apples, you might have 12,000 apples. You can still say 1,000 dozens. 12,000 apples means 1,000 dozens of apple, no? But when we are speaking about microscopic entities like protons, like atoms, like molecules, we will speak about them in terms of mole. 1 mole means very big number, sir. 6.022 into 10 to the power 23. So if 1 mole is Na, 2 moles obviously will be 2 Na. तो यहाँ से एक फॉर्मूला आ जाएगा हमारा. We will say number of entities is equal to is equal to number of entities is equal to number of moles multiplied by Na, or if I just rearrange number of moles is written like this with N, okay, is equal to number of moles is equal to number of entities अपॉन अवोगैड्रो नंबर Na. ये फॉर्मूला आ गया हमारा. कॉमन सेंस की बात है लेकिन फॉर्मूला यूज करते हैं. Very much like if I tell you, you are given 1 dozen of bananas. How many bananas we have? 12 bananas. 2 dozen तो कितना आ जाएगा आंसर? 2 into 12. 3 dozen, 3 into 12. So why you are multiplying by 12? Because 1 dozen means 12 items. So 1 mole means Na items. 2 moles will be 2 into Na. 3 moles will be 3 into Na, and so on. So number of entities in number of moles multiplied by Na. So यहाँ से ये formula आ गया हमारा. So we will use this formula, very important formula. We will use this formula yes, we will use this formula for interconversion of moles into number of items. All right, let us move ahead. How much would 1 mole of electrons and 1 mole of neutrons weigh? सिंपल है, हमको तो पता है 1 electron weighs 9.1 into 10 to the power minus 28 grams or minus 31 kilogram. ग्राम में कर लेंगे, ठीक है. So if 1 electron weighs this much, 2 electrons would weigh how much? Sir, 2 into this number. Correct. 3 would weigh 3 into this number. So 1 mole electron means how many electrons? This many electrons. This many electrons. Correct. So weight of or mass of, एक ही बात है, mass of 1 mole electrons would be mass of a single item, mass of a single electron multiplied by number of electrons. Mass of a single electron is this one. And number of electrons is 1 mole. 1 mole means 6.022. तो आंसर आ जाएगा 9.1 into 10 to the power minus 28. That is the mass of single guy multiplied by number of electrons. So if you multiply 6 into 9, you will get 54. And 0.1 into 6 is 0.6. So 54.6. But since there is 0.022, the answer will be slightly more than that. It will be close to 54.8 into 10 to the power minus 28 plus 23 is minus 5 grams. This is the weight of 1 mole particles. Acha, how will I calculate mass of 1 mole of protons? Quite simple. Mass of a single proton multiplied by 1 mole of, अच्छा, प्रोटॉन न्यूट्रॉन एक ही बात है, न्यूट्रॉन लेंगे. Mass of a single neutron multiplied by number of neutrons. 1 mole of neutrons means 6.022 into 10 to the power 20. तो आसान हो गया अभी. Mass of single neutron I told you is approximately बोल रहा हूँ 1.67 into 10 to the power minus 24 grams in terms of grams multiplied by 6.022 into 10 to the power, ये आ जाएगा. Okay. अभी of course we can multiply this, no doubt, but before we do that, Sorry about this glitch. हाँ भाई. Before I do that, let me tell you one thing. How did Avogadro get this number? Avogadro को ये नंबर आया कैसे भाई? ये नंबर आया कैसे? He simply took reciprocal of mass of a nucleon. बस. Sir, what is mass of a nucleon? Sir, it is 1.67 into 10 to the power minus 24. In terms of grams he took. In terms of grams. और जब इसको डिवाइड करोगे 1 डिवाइड बाय दिस, तो दिस नंबर विल गो ऑन टॉप. इट विल बिकम 1 अपॉन 1.67 into 10 to the power 24. And 1 upon 1.67 will give us 0.60. I know the answer. Okay, that's why I write it directly. अब इस डेसिमल को अगर यहाँ पे शिफ्ट कर ले तो आ जाएगा 6.022 into 10 to the power 23. My point is that mass of a proton and Avogadro number are reciprocals of each other. Mass of a proton is simply reciprocal of this, or Na is reciprocal of this guy. Just make sure that mass of a proton or mass of a neutron you write in terms of grams, not in terms of kilograms. Okay, so Na and mass of a proton are reciprocals of each other. Or I can say, I'll write it here. Isn't mass of a proton called 1 unit? Isn't mass of a proton called 1 unit? Yes. So 1 unit is simply reciprocal of Na. Let us write that. .022 into 10 to the power 23 is reciprocal of 1.67 into 10 to the power minus 24. This is the first thing that you must understand. Now, second thing that you must understand is that this is nothing but Avogadro's number. Correct? This is equal to 1 upon, this is nothing but mass of a proton, but in terms of grams. Third thing I may say is Na is equal to 1 upon, in terms of grams, this can be written as 1 unit. Mass of a proton is also called 1 unit. So I will rearrange this and I will say 1 unit is nothing but 1 upon Na grams. Extremely important for us. 1 unit and Avogadro number are reciprocals of each other. So when you are going to convert 1 unit, into grams, how do you write it, sir? 1.67 into 10 to the power minus 24 grams, sir. Arey baba, but this number and this number are just reciprocals, right? तो इसकी जगह हम क्या लिख सकते हैं? 1 upon 6.022 into 10 to the power 23. तो ग्राम वैसे का वैसा रहा. तो इसको हम क्या बोलते हैं? इसको बोलते हैं Na. वही तो लिखा है मैंने यहाँ पे. Okay, so 1 unit means 1.67 into 10 to the power minus 24 grams, or 1 unit is 1 upon 6.022 into 10 to the power 23 grams. ये बात है. Coming to our point here. Okay, mass of 1 mole of neutrons is mass of a single neutron multiplied by this number. अच्छा, तो ये तो ग्राम्स में है भाई. But how can I write this number? Sir, this number can be written as 1 upon 6.022 into 10 to the power 23. This interconversion you must be able to do. ये तो कैंसल हो जाएगा. Answer is 1 gram. So 1 mole of neutrons or 1 mole of protons, they are going to weigh 1 gram. Okay. How many electrons are present in 1 kilogram of electrons? Let me change this question a little bit. Let me, instead of electrons, say protons for now, then we will come to electrons. प्रोटॉन्स न्यूट्रॉन्स एक ही होगा. अभी मैंने क्या बोला 1 mole of neutrons is 1 gram. 1 mole neutrons is 1 gram. Then how many moles of neutrons is 1000 grams? Obviously the answer is 1000 moles. Correct. And now if I want to convert it into number of neutrons, then it's quite simple. So number of entities, number of neutrons is simply number of moles multiplied by Na. Number of moles we just now found out is 1000 multiplied by 6.022 into 10 to the power 23, which is 6.022 into 10 to the power 26. 23 and 1000 means 10 to the power 3. So these many neutrons are present in 1 kilogram of neutrons. What if we want to figure out about electrons? Chalo. How many electrons are present in 1 kg of electrons? It's quite simple. Sir, mass of 1 kilogram electron is simply mass of a single electron multiplied by number of electrons. Obviously, total mass is a mass of a single fellow multiplied by how many number is there. Now mass of a electron 1 kg है ना भाई, तो 1 किलोग्राम हो गया. Total mass is how much? 1 kilogram given. Mass of a single electron is 9.1 into 10 to the power minus 31 kilograms. Since this is kilogram, I have taken this also in kilograms. Multiplied by number of electrons. Therefore, I will say number of electrons is equal to 1 divided by 9.1 into 10 to the power minus 31. ये ऊपर चला जाएगा. This can be written as, I'll just rearrange, I will write this as 10 into 10 to the power 30 upon 1.1. So 10 upon 9 is approximately 1.1. These many electrons are there, and obviously 1 kilogram of neutrons will have less neutrons than number of electrons. Why sir? Because neutrons are heavy, तो कम हो जाएंगे ना 1 किलोग्राम में. If you try to buy 1 kilograms of cashew nuts and 1 kilogram of mangoes, obviously since mangoes are heavy, there would be less mangoes in 1 kilogram of mangoes. Likewise, since neutrons are heavy, there would be less number of neutrons in 1 kilogram. Okay. Alternatively, दूसरे तरीके से भी इसको सॉल्व किया जा सकता था. इसको दूसरे तरीके से कैसे करते हैं हम? इसको बोलते हैं सर मास, टोटल मास जो भी तुम लोगों को दिया है इज मास ऑफ अ सिंगल फेलो, मास ऑफ अ सिंगल प्रोटॉन मल्टीप्लाइड बाय टोटल नंबर ऑफ प्रोटॉन्स. ऐसे भी किया जा सकता था. टोटल मास कितना दिया है? 1 किलोग्राम. मास ऑफ अ सिंगल प्रोटॉन इज 1.67 into 10 to the power how much? minus 27 kilograms. Okay, grams में 24 आ जाता. Into number of protons. Therefore, number of protons is equal to 1 upon 1.67 into 10 to the power minus 27. ये हो जाता है, तो ऊपर चला जाता है. Now we know that 1 upon 1.67 is 0.6022. That is 6.022. I move this. I have to reduce here. तो आंसर तो सेम आ जाता. So answer would have been the same, but just that I took some data from the previous question. I took some data from the previous question and used it here. Okay. So, so 1 mole of nucleons weigh 1 gram. 1 mole of nucleons weigh 1 gram. चलो भाई आगे बढ़ते हैं. Molar mass. Simple. What is molar mass? Mass of 1 mole of particles. Mass of 1 mole of particles is called molar mass. So 1 mole of protons will weigh how much? 1 gram. So therefore molar mass of protons or molar mass of neutrons is 1 gram per mole. Let us repeat that. I told you 1 mole of protons will weigh 1 gram. And what is molar mass? Mass of 1 mole of particles. So molar mass of protons would be 1 gram per mole. Sir, I don't believe you. Let us see. How much would 1 mole of hydrogen atom and 1 mole of helium atoms weigh? We'll try to solve this question. Okay? तो थोड़ा सोचो अभी. सर 1 mole of hydrogen, तो थोड़ा सोचना है. मेरे पास सर एक एटम है हाइड्रोजन का, इसमें सर एक प्रोटॉन होता है और सर इलेक्ट्रॉन अराउंड इट एंड इलेक्ट्रॉन अराउंड इट. ओके. 1 hydrogen atom has 1 proton, so obviously 1 mole of hydrogens would have 1 mole of protons, and the 1 mole of protons would weigh 1 gram. So therefore we already have our answer. It is 1 gram. But no sir, मजा नहीं आया. चलो यार करते हैं. Simple. Sir, mass. अच्छा, how much weight ना? Mass of 1 mole. इसको बोलते हैं molar mass. Okay. Molar mass of hydrogen is mass of a single hydrogen atom multiplied by number of atoms. How many atoms? Sir 1 mole का 1 mole atom है ना भाई. इसका मतलब क्या है? 6.022 into 10 to the power 23. 1 mole means this number. Okay. So total mass is number of particles multiplied by mass of single particle. Single particle here is hydrogen. Sir, what is the mass of a single hydrogen? उसको बोलते हैं atomic mass. Mass of a single hydrogen atom is called atomic mass of hydrogen. I already told you it is 1 unit. तो यहाँ हो गया 1 unit into 6.022 into 10 to the power 23. आंसर तो हो गया, लेकिन हमें ग्राम्स में चाहिए आंसर. So if you remember, I had told you, and let me write it again, that 1 unit is 1 upon 6.022 into 10 to the power 23 grams. So instead of 1 unit, I can write 1 upon 6.022 into 10 to the power 23 grams multiplied by, ये तो पहले से था भाई, ये कैंसिल हो जाएगा, 1 ग्राम आंसर आ जाएगा. सर solve for helium also. Well, quite simple. Molar mass of helium is equal to number of helium atoms multiplied by weight of each helium atom. Let me not write the entire number. Let me say it is simply Na. Okay. So mass of a single helium atom is 4 unit into Na. This is equal to 4. Instead of unit, what can I write? 1 upon this number. This number is sir nothing but Na sir, gram sir, multiplied by Na. तो ये कैंसिल हो गया, आंसर आ गया 4 ग्राम्स. एंड व्हेनेवर वी राइट मोलर मास वी राइट पर मोल, ग्राम्स पर मोल. इसका मतलब है कि अगर 1 मोल ऑफ हाइड्रोजन एटम ले लें, इफ वी टेक 1 mole of hydrogen atom, its weight will come to 1 gram. Or if we take 1 mole of helium atoms, it will come to 4 grams. Is it coincidence? There is absolutely no coincidence. Single hydrogen atom, 1 unit. 1 mole of hydrogen atoms, 1 gram. 1 single helium atom is 4 units. 1 mole of helium atoms is 4 grams. So the number remains the same. Unit changes. Students get confused. When to write U, when to write G, when to write 4 unit, when to write 4 grams. Simple. When you are speaking about single atom, when you are speaking about single atom, तो unit होगा उसका U. Single atom उसको बोलते हैं एटॉमिक मास. मास ऑफ अ सिंगल एटम इज कॉल्ड एटॉमिक मास. मास ऑफ अ सिंगल मॉलिक्यूल इज कॉल्ड मॉलिक्यूलर मास. बट मास ऑफ 1 मोल ऑफ एटम्स इज कॉल्ड मोलर मास. और देयर इज अनदर वर्ड फॉर इट, ग्राम एटॉमिक मास. Single atom, atomic mass. 1 mole of atom, gram atomic mass. Basically what it tells us is that you have to simply write the same number of atomic mass, but this time write grams over there. Likewise, single molecule's weight is called molecular mass, and 1 mole of it is called gram molecular mass. So molar mass has 2 names. Molar mass has 2 names. Okay, so molar mass has 2 names. One is gram atomic mass and other is gram molecular mass. This is defined for obviously atomic species. Atomic species ना single atom वाले, hydrogen, helium, neon, xenon, so on. And gram molecular mass is defined for obviously molecular species. जैसे कि H2, O2, H2O, NH3, etc. All right. So what is the molar mass? What is the molar mass of hydrogen? Sir, atomic mass of hydrogen is 1 unit. Therefore, molar mass of hydrogen is 1 gram per mole. What is the atomic mass of helium? 4 unit. Its molar mass will be 4 grams per mole, and so on. Likewise, H2 is 2 units. Molecular mass of hydrogen is 2 units. तो इसका होगा 2 grams per mole. Water is 18 units. तो इसका होगा 18 gram per mole. So molar mass is a common term, but when molar mass of molecular species is being determined, उसको हम बोलेंगे gram molecular mass. हाँ, so molar mass in grams is numerically same as atomic or molecular mass in unit. ठीक है. Hence atomic mass expressed in grams is called gram atomic mass. Already discussed है भाई. जैसे कि हाइड्रोजन 1 यूनिट था तो उसका 1 ग्राम हो गया. हीलियम 4 यूनिट था, इसका 4 ग्राम्स हो गया. Similarly, molecular mass expressed in grams is called gram molecular mass. जैसे कि molecular mass of water is 18 units. Its gram molecular mass is 18 grams. So don't get confused over here. Whenever we use the unit grams, you must understand we are speaking about 1 mole of those particles. And whenever we use the unit U, you must understand we are speaking about a single atom or a single molecule. Okay. Now, from here, अब थोड़ा ध्यान दो. Molar mass of water is 18 grams per mole. इसका मतलब है कि 1 mole of water will contain 18 grams of water. इसका मतलब ये होता है कि 1 mole of water, if you take 1 mole of water, sir, what is 1 mole of water, sir? 6.022 into 10 to the power 23 molecules of water will weigh how much? 18 grams. So if 18 grams is 1 mole, 36 grams would be how many moles? Answer is simple, 2. If 18 grams is 1 mole, 36 grams would be 2. कैसे आ जाए? यहाँ पे फॉर्मूला आ जाएगा. Number of moles is given mass upon molar mass. जैसे कि ये इंपॉर्टेंट फॉर्मूला है. It's a very important formula. For example, if I ask you, find the number of moles of water in 54 grams water. Now, one way to solve this is simple unitary method. We can say, sir, 1 mole of water has 18 grams of water. Then, how many moles will have 54 grams? तो फिर बाद में तुम क्रॉस मल्टीप्लाई करो. x into 18, 18x equal to 54. So, x will be equal to 54 upon 18, which is 3. नहीं तो फॉर्मूला यूज कर लो ना, डायरेक्ट फॉर्मूला यूज कर लो. और फॉर्मूला इज बेटर. नंबर ऑफ मोल्स इज गिवन मास. व्हाट इज गिवन मास? 54. यू आर गिवन 54 grams of water. Divide by 3 moles. So we have 2 formulas so far. One is this one and other says given number of entities upon Avogadro number. Okay. एक सवाल पूछते हैं. Three 3.5 moles of NH3 will weigh how much? तो ammonia, the molar mass, nitrogen is 14, hydrogen is 1 into 3, so total is 17 grams per mole. That is the molar mass for ammonia. तो अगर तो आंसर इजीली आ जाएगा. नंबर ऑफ मोल्स इज गिवन मास. Now that mass you have to find out upon molar mass. Number of moles for you is 3.5. Given mass, sir, I don't know, x. Find out करना पड़ेगा ना, how much it will weigh. Molar mass is 17. So x will be 3.5 multiplied by 17. तो उसको कर सकते हैं मल्टीप्लाई. 35 into 17. $59.5. Yes, 59.5 grams. So this is how we will convert. This is how we will convert moles into mass. So two formulas, we use two formula. The first formula we use is number of moles is number of entities upon Avogadro number. Second formula we use is given mass upon molar mass. The third formula we can derive from these two is if left hand side is the same, then right hand side also must be equal. So number of entities upon Avogadro number is equal to given mass upon molar mass. ये हो सकता है. चलो. Now there is one more formula. There is one more formula which we must make ourselves familiar with. It says that number of moles is equal to volume of gas at standard temperature pressure upon 22.4 liters. Sir, ऐसा क्यों? It is found, this is Avogadro's rule. What Avogadro says is that you take 1 mole of any gas. It will occupy fixed volume. जैसे कि बोला कि if you take 1 mole of hydrogen, it will occupy 22.4 liters at STP. I'll explain what is STP. Some fixed temperature, fixed pressure we take. So if you take 1 mole of hydrogen, it occupies 22.4. If you take 1 mole of helium, that also occupies 22.4. So irrespective of which gas you have, 1 mole of that gas will occupy fixed volume. At STP it is 22.4. So 1 mole of any gas at STP will occupy 22.4 liters. Sir, what is STP? Standard temperature pressure. Standard temperature pressure means standard pressure is taken as 1 bar and standard temperature is around 273 Kelvin. तो थोड़ा ऊपर नीचे हो जाता है, थोड़ा confusion होता है बच्चों को. But don't worry, you don't have to worry about what the STP conditions are over here right now. You have to just know that at STP 1 mole of any gas will occupy 22.4 liter. Very much like 1 mole of any substance will weigh molar mass, or 1 mole of any substance will have Na number of particles. Likewise, 1 mole of gas occupies 22.4 liters of volume. Moving ahead, let us try to solve one question and then we will end it. Okay? तो एक सवाल करेंगे. Which of the following has more number of atoms? One is 16 grams of oxygen atoms, or 2, 16 grams of O2 molecules. All right. So which one of them will weigh more? Try to find out. We'll solve it. Yes. So which of the following has more number of atoms? Fine. It's always better, whenever we are asked to find the number of atoms, it is better to follow these steps. हमारा पहला स्टेप होगा, यहीं पे लिख लेता हूं. Our step 1 is find number of moles. Find the number of moles. How to get the number of moles, sir? We are given mass. How to convert mass into moles? That's quite simple. Number of moles is given mass upon molar mass. Okay. Sometimes number of particles may be given. We will use different formula. Okay. The step 2 is now convert number of moles into number of molecules. Convert number of moles. Convert number of moles to number of molecules. That is also quite simple. Sir, number of moles is number of molecules divided by 6.022 into 10 to the power 23, or that number of molecules is equal to number of moles which we found in the step 1 multiplied by Na. Na means 6.022 into 10 to the power 23. And step 3 is going to be find number of atoms. How to find number of atoms? Well, that is simple. Number of atoms is equal to number of molecules from step 2 multiplied by atomicity. Sir, what is atomicity? Number of atoms present in any molecule is called atomicity. For example, O2. O2 में 2 atoms है, तो इसकी atomicity 2 हो गई. H2O has 2 hydrogen atoms and 1 oxygen atom. So its atomicity is 3. Likewise, NH3. N, there is 1 nitrogen atom. There are 3 hydrogen atoms. Total atomicity is 4. CH4, single carbon atom, 4 hydrogen. Total atomicity is 5. Let us try to follow this. Okay. Now, 16 grams. चलो, first one. तो हमारा स्टेप 1 होगा नंबर ऑफ मोल्स. नंबर ऑफ मोल्स इज गिवन मास 16 ग्राम्स अपॉन मोलर मास. ना मोलर मास किसका लोगे तुम? मोलर मास इसका लोगे तुम. ऑक्सीजन का मोलर मास है 16 ग्राम्स पर मोल. तो 16 by 16 आंसर विल बी 1 मोल. ओके. सेकेंड स्टेप, convert number of moles to number of molecules. Actually, we don't have to. Why? Because there are no molecules in it. You are already given number of oxygen atoms. So skip 2. Or if you want to do, you can say that number of molecules will be same. 1 mole hi hoga wo. Okay. Then find the number of atoms. Number of atoms is equal to 1 mole. Number of moles into Na. Number of moles beta 1 है, and this is 6.022 into 10 to the power 23 atoms. So this is 6.022 into 10 to the power 23 atoms. I did not convert into molecule क्योंकि molecules उसमें है ही नहीं भाई. So I directly converted moles into number of atoms. Second one, first convert this into number of moles. Number of moles is given mass 16 upon molar mass is 1 oxygen is 16, 2 oxygens are 32. So molar mass is 32 grams per mole. So 16 by 32, it is 1 by 2 mole. Step 2, find the number of molecules. Achha, there are molecules. Okay. So number of molecules is number of moles into Na, that is half into 6.022 into 10 to the power 23. This is the number of molecules. And once I have got the number of molecules, finally I will find number of atoms. Sir, number of atoms कितने हैं? Number of molecules into atomicity. Number of molecules is 1 by 2 into 6.022 into 10 to the power 23. Number of molecules into what is the atomicity? Sir, atomicity कितना है इसका? There are 2 atoms in oxygen. Therefore, so answer is 6.022 into 10 to the power 23. That is, whether you take 16 grams of oxygen atoms or whether you take 16 grams of oxygen molecules, they are going to have same number of atoms. चलो तीसरा ऐड कर लेता हूं यार, मैं तीसरा ऐड कर लेता हूं. 16 grams of ozone molecules. इसको कैसे करेंगे सॉल्व? सर, फर्स्ट स्टेप इज फाइंड नंबर ऑफ मोल्स. नंबर ऑफ मोल्स इज गिवन मास अपॉन मोलर मास. व्हाट विल बी मोलर मास? 1 oxygen is 16. 16 into 3 is 48. So this will give us 1 by 3 moles of ozone. दूसरा स्टेप, number of molecules. Number of molecules will be how many? Number of moles multiplied by Avogadro number. Now, number of atoms will be how many? Number of molecules multiplied by what is the atomicity? One ozone has how many atoms? 3 atoms. So atomicity is 3. तो ये तो कैंसल हो गया भाई. So whenever somebody asks you a question, which of the following has more number of atoms? 16 grams of oxygen, 16 grams of O2, 16 grams of O3, same होगा. If the mass is same, the number of atoms for that same element will be same. जैसे कि अगर मैं दे दूं 10 grams of hydrogen atoms, 10 grams of H2 molecules, number of atoms will be same. In the fixed mass, number of atoms of a particular element will be same. लेकिन if I ask you to find out, find number of atoms in 16 grams of H2 and 16 grams of helium, तो आंसर अलग हो जाएगा. सो आंसर विल नॉट बी सेम. देख लेते हैं कैसा होता है. फर्स्ट कैसे करेंगे सर? सर, नंबर ऑफ मोल्स इज गिवन मास अपॉन मोलर मास. व्हाट इज द मोलर मास ऑफ हाइड्रोजन? 2 grams per mole. What is the molar mass of helium? 4 grams per mole. So 16 by 2, you will get 8 moles. Now, number of molecules is number of moles into Na. Na is 6.022 into 10 to the power 23. Number of atoms, third step. Number of atoms is number of molecules multiplied by atomicity of hydrogen is 2. So answer hoga 16 Na. These many atoms are present. In case 2, 16 grams of helium is given. First, find the number of moles. Number of moles is given mass upon molar mass. Answer is 4 moles. मोल्स तो मिल गए सर हमको. अभी क्या चाहिए? नंबर ऑफ मॉलिक्यूल्स. अरे मॉलिक्यूल्स है ही नहीं भाई उसमें. हीलियम इज एन एटॉमिक स्पीशीज. मोनो एटॉमिक स्पीशीज बोलते हैं उसको. इट डजंट बॉन्ड विद एनीवन. इनर्ट गैस है. सो नंबर ऑफ एटम्स डायरेक्टली फाइंड आउट करने का. So I will, second step is not number of molecules, number of atoms. Formula तो same रहेगा. Okay, it will be number of moles into Na. Right? वो obvious सी बात है. See, hydrogen will weigh less, 2. Okay, and helium weighs double of that. How much? 4. So obviously the number of atoms over here will be less than number of atoms, because this guy is light, right? This guy is light. H2 weighs 2 grams, single hydrogen will weigh 1 gram. So obviously helium will have 4 times less number of atoms. Hydrogen weighs 4 times less. Therefore, number of atoms of hydrogen will be 4 times more than number of helium atoms in a fixed amount of mass. जैसे कि मैं बोल दूं अभी, so for example say that we are given pens, okay, and let us say that one pen weighs 10 grams, okay, and then I am given another marker. Let us say marker ले लिया यार हमने, ये marker ले लिया, ये 10 ग्राम है, ये 20 ग्राम है, तो इसका वेट तो डबल हो गया. So if I am given 100 grams of pens and 100 grams of marker, तो 100 ग्राम में कितने पेन्स होंगे? वन फेलो हैज 10 ग्राम, सो 100 ग्राम में इसके 10 आ जाएंगे. इसके कितने आ जाएंगे? ये एक है 20 ग्राम का, 100 ग्राम में कितने आ जाएंगे? 5 आ जाएंगे. Why? Because this fellow is heavy, and since this fellow is heavy and it is double than this, the number of markers will be half. Likewise, when we speak about hydrogen and helium, hydrogen is 4 times lighter. Therefore, number of hydrogen atoms in a fixed amount, ये amount fixed अगर है तो उसमें 4 गुना होगा, 4 times it will be. We will solve one last problem, okay, before we stop. Let us say that we are given 18 grams of water and we are asked to find number of electrons, number of protons and number of neutrons in 18 gram of water. Find number of electrons, protons and neutrons in 18 gram of water. So problem we will start like that only. We will start like that only. We will find first number of moles. Number of moles is given mass upon molar mass. So I have 1 mole of water molecules. We have 1 mole of water molecule. अभी थोड़ा सोचो इसके बारे में. If you have 1 water molecule, that means you have 2 hydrogen atoms and 1 oxygen atom. ये मानते हो? अच्छा, hydrogen has 1 proton, oxygen has 8 protons and 16 nucleons. Okay, fine. So 1 molecule has 2 hydrogen atoms and 1 oxygen atom. Therefore 1 mole means Na water molecules will have how many hydrogen atoms? So number of hydrogen atoms. You tell me how many hydrogen atoms are present. सर थोड़ा डिफिकल्ट हो जाएगा. यू फर्स्ट फाइंड आउट सर नंबर ऑफ हाइड्रोजन मॉलिक्यूल्स. नहीं यार, ऐसा नहीं कर सकते. नंबर ऑफ हाइड्रोजन और नंबर ऑफ वाटर मॉलिक्यूल्स. यू फाइंड सर नंबर ऑफ वाटर मॉलिक्यूल्स. स्टेप बाय स्टेप करेंगे इसको. फाइंड नंबर ऑफ वाटर मॉलिक्यूल्स. अच्छा, 1 मोल multiplied by Na. This is the total number of molecules. 1 molecule of water has 2 hydrogen atoms, right? So atomicity of hydrogen is 2 and atomicity of oxygen is 1. Okay, so now if I try to find out number of hydrogen atoms present, then how will I find out? Sir, number of molecules multiplied by atomicity of hydrogen is 2. तो आंसर आ जाएगा 2Na. If I try to find out number of oxygen atoms, it will be number of molecules, which is Na multiplied by its atomicity is 1. तो Na हो गया भाई. Correct. Now, if I try to find out the total number of atoms, total number of atoms is number of molecules, that is Na multiplied by atomicity. Total molecule की ही atomicity 3 है. आंसर होगा हमारा 3 times Na. Okay, fine. Let us move ahead. Find the number of electrons, protons and neutrons. हमने तो atoms पूछा नहीं था, लेकिन we tried to find out. Single water molecule will have, see here, how many protons? 8, 9, 10 protons. So here number of protons is 10. Number of neutrons, let's try to find out. Neutrons here are 8. Sir, 16 minus 8 is 8. Here 1 minus 1 0. So total number of neutrons is 8 and total number of electrons will be 10. Number of protons and number of electrons will be same. Now you tell me, if single water molecule has 10 protons, then Na molecules will have how many protons? Total number of protons is the number of molecules multiplied by, एक molecule में कितना है? 10 protons. So answer will be 10 times Na. Number of electrons also will be 10 times Na. And number of neutrons will be, sir, there are 8 neutrons in a single molecule, therefore 8 times Na. Of course, you can replace Na, substitute for it and multiply it by 6.022 into 10 to the power 23, you will get the answer. But I am keeping it as Na. If you want, you can replace, in place of Na, you can write 6.022 into 10 to the power 23 and you can multiply it and get the final answer. So I hope that you followed the mole concept. We discussed about the atomic, the molecular masses as well as molar masses, and how to interconvert, how to convert moles into grams, how to convert grams into moles, and how to count number of electrons, how to count number of atoms present inside. So that's it for today. I'll see you next time. Thank you so much.